Alright, what we're going to do is we're going to create a foldable for the gas laws. There's 4 of them. I had you look at 3 of them, and I'm going to be taking a look at all 3 of those after we get done with this. But I want to make the foldable first. And what we need to do is, I'll zoom it out a little bit. I'm making a nice little video, so if you forget how to do this, or if you know people who are absent, they can do this. We want to go horizontal, so we want the paper sideways. And what you're going to do is you're going to fold it in half. So you'll end up folding it in half. And then what we're going to do is we're going to create 4 openings. So, before you guys go crazy and start cutting, they don't have to be 100% perfect, but if you're one of those people that needs it to be 100% perfect, we have rulers that you can measure. So we're gonna make 4 openings. It doesn't matter what side. Because for mine, it's going to open up to the left like this. If you want it to open up in a different direction, then by all means, that's you. If you want to flip it and you want it to open it up this way, rock on.
Wait, do we cut both?
What you'll do is you'll fold it. You only cut one side. So you have 4 openings. And then you're going to glue that thing to your piece of paper. The side that you did not cut, you're going to glue. Ironically enough. Or tape if you want tape instead. We have tape up here. But don't use all my tape. Then you glue it to your notebook. Yeah, the solid side that you did not cut is the side that you keep down. Now, for the sake of the video, I know you guys are still working on that. You talked about, I had you guys research 3 of the laws yesterday. Boyle's, Charles, and gay-lussacs law. And they're all named after somebody. So the first one's going to be Boyle's law. And what I did right here at the front, I put C, and then I made an arrow to T, basically saying that the constant in Boyle's law is temperature. So,
Yeah.
Can you actually see what we're doing? Yeah, of course. All right. Okay, so that's the first one. The second one is Charles's law. So Charles and the constant is pressure in this case. And then you have gay-lussacs law. where the constant, if temperature was the first one, pressure was the second one, what do you think the constant is in the third one? Volume. Because the three variables are always pressure, temperature, and volume. And then the last one that we're going to have is the combined gas law, which is going to combine all three laws, and we don't hold anything constant in that case. Unfortunately, I don't think I really can. It goes Boyles, Charles. I'll write them up on the board here. That doesn't help. How are we on this? Because we have to get into and actually write stuff for each of the laws. Actually, let me do this. All right, can I start talking about Boyle's law? Yeah. We're good to go? All right, Boyle's law. Over on this side, I put at a constant pressure, or at a constant temperature, sorry. P1 V1 is equal to P2 V2. That's the law. But over here, we can also put that as pressure increases, volume is going to decrease. But also as pressure decreases, volume is going to do what? Increase. So as one increases, the other decreases. Now the nice thing is, Boyle's law is the only one that does that. The other two laws, as one increases, the other increases. As one decreases, the other decreases, which is nice for us. But this is what you need to have. So if you need Boyle's law and you need the formula, there's your formula. These guys right here are usually referred to as initial conditions. And then this usually represents where you changed either pressure, you changed the P2 value, or the V2 value. So you either changed volume or pressure. But if you changed volume, pressure will change accordingly. If you increase the volume, then pressure will decrease. If you decrease the volume, pressure will increase. We're going to go over demonstrations of all of these. Changed either P2 or V2. And that's going to be the same thing for each one. This is going to be your initial conditions. This is what we started off with. This is when you either changed this guy or you changed this guy. Alright, so. Alright, I'll wait. don't think I need these anymore. So, let me find the perfect spot for this. All right. Now let's move on to the next one. Charles' law. Constant is pressure. So we're going to get an equation that doesn't have pressure in it. Over here, at a constant pressure, as temperature increases, volume increases. Or as temperature decreases, volume decreases. Or volume decreases, temperature decreases. That's how it kind of comes up. And the equation is V1 divided by T1 is equal to V2 divided by T2. And the first Terminator. It's like T2 all over again, that whole movie. So at a constant pressure, you're going to have your temperature and volume left over to deal with. And that's what Charles' law has talked about. Like I said, we're going to have demos on each of them. All right. I still see pencils furiously writing. And phones furiously being used. Because, heaven forbid, that you don't use your phone. All right, can we move on to gay-lussacs law? Everybody okay? Put it right there. All right, gay-lussacs law. The third law. Has a constant volume. So, not as, at a constant volume. As pressure increases, temperature will increase. Or, because since the volume's constant, we're talking about pressure and temperature. We already talked about volume and temperature. Now we're talking about the relationship between pressure and temperature. As pressure decreases, temperature will decrease. So this is a way to kind of change boiling points and things like that, which is really cool. It's going to end up being P1 over T1 is equal to P2 over T2. If you haven't noticed, of the three equations, there's only one where it's just two things being multiplied. P1 V1 equals P2 V2. Which sounds like robots from Star Wars. Then you have V1 over divided by T1 over V equals V2 divided by T2. And now you have P1 divided by T1 is equal to P2 divided by T2. Now, is everybody okay with these? All right, now the combined gas law puts all three laws together. So we have wonderful equations. And it is, let me close that top there. P1 V1 divided by T1 is going to be equal to P2 V2 divided by T2. Now, the neat thing about the combined gas laws is if you keep something constant, if you keep temperature constant, that's Boyle's law right there. If you keep pressure constant, that's Charles' law right there. And if you keep volume constant, no, my fingers aren't working. Then you get gay-lussacs law. And the neat thing is if these are constant, if these values are the same, then V1 would equal to V2 and they divide out. T1 would equal to T2 and they would divide out. P1 would equal to P2, they divide out. And you get back to the three laws. So as long as we keep things constant, we can always go from the combined gas law back to the regular laws. But this is going to be for any gas. If you have a pressure, a volume, and a temperature, and you keep the conditions constant, and then you just change pressure, and you might change pressure and volume. All this stuff is going to change, and you can calculate that. Yes, sir?
It's like we don't know which equation to use. Just use that equation and tell us which one to use.
Yes, but they'll tell you what's constant. So if they say at a constant temperature, then you know that just by looking at this, you say, oh, which one has the constant temperature? Boyle's law has the constant temperature. And if they only give you, for example, temperature and volume, then you're going to go to the volume and temperature equation. So that's why you want to have all three equations, or all four equations right at your fingertips. If they give you all three values, you know you're going to use the combined gas law. But if they're only giving you two values, then you know that you're going to be using either one of the three laws up top. And we're going to go over some examples. Before we get into actually some demos on these and some other stuff that we're going to be doing with that. But first off, this foldable, everybody okay with it? All right, now, the video will be up. I'm going to put that up in a second here. But I'm going to zoom this out. Well, that's as much as I can. And open this up so people can make sure. Over here, I'll put Boyle. I'll put Charles. Gay-Lussac, and combined. So at least you have all three of them, or all three of them and the combined gas laws. And while I set the video up to get put out.